Yeah. In this session, we will be focusing on looking at the short-term interest rates. We will look at the short-term interest rates and what kind of impact they have with the term structure of the interest rates, and how does the volatility of the interest rates impact the term structure. And we will introduce to a concept of, or probably will relook at the concept of convexity, based on how is the convexity impacted. One, with the maturity period, we'll try to see what are the factors that will impact the convexity of a bond, primarily looking at the maturity as well as the volatility of the security, or volatility of the underlying interest rates, and based on that, see if at all I have to look at incorporating a risk premium into the term structure and do the pricing of the bond. How will I go forward doing that? So these are some of the key things that we would cover as a part of this session. So, to start with, the term structure. What is this term structure? What are going to be the interest rates over the next few years? A kind of depicting of the interest rates for the future is what we are calling as the term structure of the interest rates. What are going to be the spot rates? Probably what is the 1 year spot rate, 2 year spot rate, 3 year spot rate, or probably long term rates. Now what we are saying is these rates are purely based on the expectations of the future short term rates. Right, this was actually propounded as a part of our expectations theory also here, but when we use the word here, we are using it in a slightly different context. The expectation of the future interest rates. So the word itself is saying expectation of the future short-term rate. There are two ways of putting it. Okay, right now if the interest rates are 7%, if I am saying the next year also the 1 year interest rate is going to be 7%, means 1 year spot rate next year is going to be 7%, or this is an expected rate. I am expecting that the 1 year spot rate next year is going to be 7%, or the other way of saying it is, yeah, the expected rate is 7%, but the possibilities are there could be 8% or 6% with equal probability. Still the expected is 7, right? But there is a difference between saying the interest rate next year can be 8% or 6% versus saying the interest rate next year is expected to be 7%. That is what we are trying to highlight in this particular session, because whenever we deal with this concept of the shape of the term structure or the yield part, we always deal with these expected values kind of scenario. For example, if I assume currently the interest rate is 7%, and probably 1 year from now also, right, or probably the current 1 year spot rate is 7%, and 1 year forward is 7%, and 1 year forward 2 years from now is also 7%, which means the expectation of the spot rate in each of the years is going to be 7% itself. Then probably all I can say is a 1 year spot rate is also 7%, 2 year spot rate is also 7, and 3 year spot rate is also 7. Whereas let's say if the expected rates, right, if the expected rates for the next 3 years, 1 year rates only, I'm expecting that the current year the 1 year rate is going to be 7%. In the next year I am assuming that the 1 year rate is going to be 8%, and the year next to it, if I am assuming that the 1 year rate is going to be 9%. Right now, if I have to do a pricing for the 2 year spot rate, right, this we have done earlier, this we know the process. If at all I have to find out the 2 year spot rate, I'll take the geometric mean of these two things. So I will take it as 1 plus 7% multiplied by 1 plus 8%. I'll take the square root, or probably I'll take the multiplication of these two raised to the power of 0.5 minus 1, saying that the 2 year spot rate for me, based on this logic, the 2 year spot rate for me is going to be around 7.5%, because this is nothing but if I am depositing $100 for 1 year, which is deposited at 1.07, and the same proceeds are deposited for 1 more year at the rate of 8%, because after 1 year the 1 year rate is going to be 8%. I am getting 115.56. The same thing if I am depositing if I am investing for 2 years at a stretch at this particular rate, it should give me the same number. That is the logic behind the deciding of a 2 year spot rate. Same way I can go ahead deciding the 3 year spot rate, which is nothing but the multiplication of these three raised to the power of 1 by 3. And the multiplication of these three which is nothing but the geometric mean of 1 plus these these rates. So raised to the power of 1 by 3 minus 1. So the 3 year rate for me, the 3 year spot rate at this moment is somewhere around 8%. So what we are seeing is, if the expectations of the short term rates are increasing, we see that the spot rates will keep increasing. If the expectations are decreasing, we see that the spot rates are also decreasing. So what we can clearly say here from this kind of a statement is, I can expect my yield curves to be either flat. Yield curve is nothing but the curve that I am plotting with the maturities on x-axis and the spot rates on the y-axis. So probably in this case we are seeing 7, 6.5 and 6. It's like a falling yield curve. But if I am expecting that in the short run the interest rates are expected to go up, then I am seeing 7, 7.5 and 8, which is spot rates are going up. So this is like an upward sloping kind of a curve, this is a downward sloping kind of a curve, or sometimes even I can have a yield curve to be flat itself. This kind of spot rates are quite drastically observable, are based on the expected spot rates. This expected is one of the important words. What I am expecting as the spot rate next year. It may be one single figure, and if it is one single figure, what we are looking at is based on that I am seeing whether the yield curve is going up or going down. Whereas when it comes to long term, probably people may not depend very heavily on the expected values. They generally, what they do is they assume that the real rates as well as the inflation, they will be constant in the long term. Now, instead of taking, now the whole point that I would like to drive is, instead of taking 8% for the next year, if I go with just a small change, instead of considering 8% for the next year, or probably I will talk about a flat curve, that is much more easier to understand. If I am talking about a flat curve of 7%, right now, just as a small change, instead of expecting that the next year interest rate is expected at 7, if I take that it may be 8 or 6, even with 50% chance, 50% chance of 8 and 50% chance of a 6, even then the expected value is going to be 7 itself. Now, is there any kind of a difference in the value of the bond going with these two assumptions? At the end of 1 year, I am assuming that this the spot rate here, instead of directly assuming an expected value of 7, I say there is a 50% chance of an 8 and a 50% chance of a 6. If we have to look at it, let's say we talk about a 2-year zero coupon bond, right? We'll talk about a 2-year zero coupon bond with a face value of 100 at the end of 2 years. Now, if I have to discount this, right? If I'm taking an expected rate of 7%, all I can do is the present value at the end of 1 year is going to be something like this, which is 93.45, whereas at the end of 1 year, or at the end of 0, or currently at this moment, the present value of that is going to be 87.34, which means the value of the bond has to be 87.34 if I am going at with 7% as the interest rate at the end of, or probably 7% is the expected spot rate for 1 year from now for 1 year. Whereas on the other side, go ahead with the risk neutral kind of an approach. So in this case, if at all the interest rate is going to be 8%, the value of the bond is going to be 100 by 1.08, right? If the value of the bond, if the interest rate is going to be 8% after 1 year, the value of the bond is going to be 92.59. If the interest rate is going to be 6% at the end of 1 year, the value of the bond is going to be 94.33. Now, there is a 50% chance that this is the value, there is a 50% chance that this is the value. So, if I want to find out the value here, probably I will apply 50% chance of 92.59 plus 50% chance of whatever 94 point something. This entire thing I am discounting it by the current 1 year rate, 7%. Now, this is working out to 87.35. Earlier, the value of this was 87.34, but the moment I have changed the interest rates slightly, I am getting that the value of the bond is going to be 87.35, slightly more higher, higher compared to the earlier approach, which means if at all it has to be the same as the previous value, if at all it has to be the same as the previous value, the interest rate, the effective interest rate is not 7, it may have to be slightly less than 7. Now, if I have to really rework it out, let's say if the interest rate has to be, if the price is 87.35, so if I am assuming that this is the PV, this is the FV, I can find out the rate now. So I'll try to find out what is the interest rate going with all these things. The number of periods being 2, the There is no PMT in this. The present value being 87.35 and the future value being 100. I find the rate in this example probably to be 6.995% instead of 7%. I'm seeing that the net effective interest rate in this case is 6.995% instead of 7%, which is an indication that if I'm taking it as an average or expected value, I'm getting the net rate as 7%, but if I'm taking it as 8% and 6% separately, because of the volatility, I'm getting the net effective rate of return as only 6.995%, which is also the case that because of this difference between 7% and this 6.995%, which is around 0.004%, 0.005% are 5 basis point zeros, right? 0.005%, which is nothing but 0.5 basis points. So this 0.5 basis points is the is what we call as convexity effect. Whatever the difference that we have got, the 0.5 basis points in this example is what we have got as the convexity effect. And now what we would see is, instead of 8 and 6, if this has been 9 and 5, still you look at it, don't change anything else, I'll just make it 9 and 5. The moment I have made it 9 and 5, still the expected value is 7 itself, right? The expected interest rate for this period is still going to be 7% itself. But what we are seeing is now the effective interest rate is only 6.981%, which means there is 1.9 basis points difference between the actual 7% and the perceived value and the effective value of 6.981%. So this 1.9 basis point is what is adding up to the convexity effect, which means the better way to look at is, if the volatility in the interest rates is much higher, what I could see is the value of the bond. Now even if you see the what is the value of the bond here, 87.34 means corresponding to a non-risky, we are seeing that if the volatility is higher, the value of the bond is actually going up. The value of the bond is actually going up, resulting in a net return of only 6.981%, right? Which is what is resulting in 1.9 basis points contributing to the convexity effect. And the convexity effect can very well be understood even using the Jensen's inequality kind of a scenario, wherein I will find out the expected value of 1 by 1 plus r's, right? Probably if I am talking about 7%, 8% and 6% kind of results. So if I have to find out the expected value of that, it is nothing but there is a 0.5 probability of 1 by 1.08 plus there is a 0.5 probability of 1 by 1.06. So which is working out to, so it is expected, so left hand side expected value of 1 by 1 plus r is actually coming out to 0.5 by 1.08 plus 0.5 by 1.06. So this is working out to somewhere around 0.9346, whereas the right hand side 1 by expected value of 1 plus r. So this is working out to 1 by 0.5 times 1.08 plus 0.5 times 1.06. So this is working out to 0.935457. So this difference again you are finding that the left hand side is greater than the right hand side. So what you will find is that difference is primarily because of the convexity effect itself. So this is what is the Jensen's inequality effect. Probably you can change. See, sometimes what could very well happen is with respect to the time period. See here, instead of 8 and 6, I have changed it to 9 and 5, or probably you change it to 10 and 4. You will find the difference is 4.2 basis points, which means you can very well see that the convexity effect is much higher if the volatility in the bond is, if the volatility in the interest rates is very, very high. Along with that, I would also suggest that if the time to maturity is higher, probably I would see, let's say I am seeing only 8 and 6 itself, but for the next period also I am considering, instead of a 2-year bond, I will consider a 3-year bond, wherein I will consider the rates as 9, 7 and 5. Instead of just considering 8 and 6, I am just considering some kind of volatility in each of these rates, and the bond maturing at the end of 3 years. So the same logic if I am applying, if the bond matures, I mean if the interest rate, the 1 year interest rate is 9%, the value at the end of 2 years for the bond is going to be something like this, right? If the bond is, if the interest rate at that time is going to be 7%, this is going to be the value, and if the interest rate is going to be 5% after 2 years, this is going to be the value. Now, boiling it down to the 1 year rate, where the interest rate could be 8 and 6. So I can say that there is a 50% chance of this being the value, and another 50% chance of this being the value, and these two things I am discounting it at where the interest rate being 8%. So this is the value at the end of 1 year. The same logic if I am applying, there is a 50% chance of this being the value, and another 50% chance of this being the value, and these two things being discounted at 6%. So at the end of 1 year, there is a 50% chance that the value of the bond is going to be 85.74, and there is another 50% chance that the value of the bond is going to be 89. Now the same logic I can carry on here, because all the 3 years the expectation is 7% only. That is what I wanted to drive, right? So here again 50% chance of the value becoming this, another 50% chance of the value becoming this. This entire thing I am discounting it by the 7%. So the value of the bond is going to be 81.65. Now if I am trying to find out what would be the effective rate for this entire period, now it's a 3-year bond, 0 being the PMT, the present value being 81 and the future value being this, I will get my 3-year rate in this case being 6.988%. Earlier it was 6.995%, but now it has become 6.988%, which means there is a gap now of almost 1.2 basis points, which means there are two important factors that are impacting the convexity, one being the time to maturity and two being the volatility. So the higher the volatility in the interest rates, I may see that the risk layers are more higher, means the effective rate of return that is coming out will actually come down. The same way, if the time to maturity is increasing, even the convexity also increases. This is what is something that we have to be comfortable with, because the price to yield relationship becomes more and more convex as the volatility increases as well as the time to maturity increases. So these things need to be figured in when you are typically going ahead with pricing, because these things have to be incorporated as a part of the price. Then moving further, we are also looking at how do we incorporate that risk premium, right? We are taking a risk now. So if we are taking a risk, we have to be compensated with a higher return. So whatever may be the interest rate at each of the periods, so probably if I am talking about 7 and assuming that these are 8 and 6, and probably assuming that these are 9, 7, 5, whatever are the interest rates I am considering at each of the layers, what we are saying is, if at all we are going ahead for incorporating the risk premium, right, we have to really look at, if at all I am considering these kind of rates, yeah, whatever it is going to cost me, it is slightly higher than if it has been see, if at all I am going for the same 7% for the next 1 year, the price of the bond has to be 87.34. But if there is a volatility, it is showing that the price of the bond is actually 87.35. 87.35 is actually resulting in a slightly higher rate of return. Now what we are saying is I have to incorporate that part as a part of my expected return, because if I take a slightly higher risk, it should result in a higher rate of return for me. So in this example itself, let's say if I am not going for any kind of compensation for this volatility that I am taking in, I may have to pay 87.3515 for this. But if I assume that because I am taking this kind of risk, I would like to get compensated by around 0.2 basis points. I would like to get compensated by 0.2 basis or probably 0.2%. I would like to get compensated by 0.2%. So which means this is actually becoming, I am saying I would like to look at this number as 8.2%, and at the same time I would like to look at this number as 6.2%, because I am taking some additional risk. What is coming out is, now if at all I have figured in a premium of 20 basis points, which is 0.2% into this model, because there is a volatility that is existing. If I say because of that additional volatility that is present in the interest rate, I would like to have an additional premium of 20 basis points. It is coming out that I need to pay 87.1885 for this particular security. which means as a compensation, what is the real return that I am going to get? So basically this is the kind of a benefit that I am going to get because I am trying to pay a slightly lesser amount. And how is that lesser amount getting worked out? If I look at the same 8%, right, I would like to look at the 8% scenario, the 7%, typical 7% scenario itself. Had I taken the 7%, these are the numbers. Had I taken just 8 and 6, right, instead of 8.2, if I had taken 8 and 6, okay, 8 and 6. So these are the prices. At the end of 1 year, it's going to be 92.59 with a 50% and 94.33 with another 50%. So obviously it is coming out it is coming out that the overall price at the end of 1 year is going to be 50% times 92 plus 50% times 94. So this is going to be the expected price at the end of 1 year. I am buying it at 87.18. So what is my expected return during this period? This minus this divided by this. So overall this is resulting in a 7.2% overall return for me because I have figured in 20 basis points as a part of a risk premium adjustment into each of those possible movements. I am ending up buying that at 87.1885, and if I am buying that particular, if the price of it is 87.1885, the expected return for the entire process is going to be 7.2%, which means overall I am getting compensated for the extra risk that I am taking. So generally while doing the pricing of any security, if at all there is a volatility, there is a volatility premium that is getting incorporated into each of the interest rate movements to accommodate for the risk, and that in turn will result in the higher return on the investment as we are seeing as a part of this particular exercise. Alright. So these are some of the things that we are talking about as a part of this session, wherein the focus was primarily on looking at instead of considering an expected value, if we see the term structure of the interest rates including the volatility, what is the kind of impact that comes and how the convexity can be determined using that particular concept, and how it would help us in doing a risk how to incorporate that risk in pricing of the securities. I hope this session has given a decent level of insight into understanding of these concepts. Any further queries regarding the same, you can very well get back to me by giving me a call on the number there, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.